We have the integral of e to the negative theta times the cosine of 2 theta d theta. In a moment, I'm going to ask you to pause the video and do the work on your own and then come back. To make sure that we're all on the same page, let's go ahead and identify u as the cosine of 2 theta. And that'll make dv e to the negative theta d theta. We'll talk about my reasons for choosing it this way after we do the work, but go ahead and pause the video now and get as far as you can. I'll tell you though, just a warning, you may get stuck or hit a wall or confused at some point in this problem. Totally fine. Come back and then we'll straighten it out. Since u is equal to the cosine of 2 theta, we know that du is equal to negative 2 sine of 2 theta d theta. Since dv is e to the negative theta d theta, v is negative e to the negative theta. Fleshing out the integration by parts formula, we have that uv is equal to negative e to the negative theta times the cosine of 2 theta minus v du. And v and du both have minus signs in front of them. So we're going to have minus the integral of e to the negative theta times 2 times the sine of 2 theta d theta. At this point, we still have a product that has the exponential and the trig function in it. We haven't made anything simpler, but we haven't made anything worse. And the way to go here is we roll through this again. So I'm going to identify u as the trig portion. We had u as the cosine of 2 theta before. It was the trig portion. So I'm going to stick with u as the trig portion. And v, or dv, was the exponential. dv is still going to be the exponential. We got to stick with what we've already done if we have to go through this with successive iterations. Otherwise, you'll undo what you've done and it'll just be confusing and not correct. Since u is the 2 times the sine of 2 theta, du is 4 times the cosine of 2 theta d theta. And since dv is e to the negative theta d theta, we have v is once again negative e to the negative theta. Using the integration by parts formula just on this uv and then v du, we have negative 2 times e to the negative theta times the sine of 2 theta, that's our uv, minus the integral, but v has a negative factor, so that becomes plus here. And what I've done is I've taken the 4 as a coefficient of cosine 2 theta, pulled it outside in front of the integral. I often do that. Anyway, we have plus 4 times the integral of e to the negative theta cosine of 2 theta d theta. That, folks, was just the integral portion of what we had already written. We still need to have the term negative e to the negative theta cosine of 2 theta. And so what we have is negative e to the negative theta cosine 2 theta minus all of the new uv minus the integral of v du. Distributing that minus sign is actually going to get us something here that we're going to be able to use in just a moment. So we have negative e to the negative theta cosine 2 theta plus 2e to the negative theta sine of 2 theta minus 4 times the integral of e to the negative theta cosine of 2 theta d theta. And now we may be thinking, well, let's use integration by parts again. But folks, if we compare what we have now in our integrand, this integral of e to the negative theta cosine of 2 theta d theta, with what we originally started with, it's the same integrand, e to the negative theta cosine of 2 theta d theta. I am now going to refer to that original integral as I, and say that I is equal to negative e to the negative theta cosine of 2 theta, bear with me here, folks, plus 2e to the negative theta sine of 2 theta minus 4i. It's the same integral. It's now showing up on both sides of the equation. We can collect the like terms by adding 4i to both sides of the equation. Looks like my pencil kept wanting to write pi there. Anyway, we have 5i is equal to, I'm going to reverse the order of the terms now because I have a leading negative, and if I can avoid that, I will. Just one of my idiosyncrasies. 5i is equal to 2e to the negative theta times the sine of 2 theta minus e to the negative theta cosine of 2 theta. I'm also in the next step going to factor out the e to the negative theta, but folks, I don't want to know what 5i is. I want to know what the integral is. Dividing both sides by 5 is going to give me that the integral is equal to 1/5. And then I'm going to pull out that e to the negative theta times the quantity of 2 sine of 2 theta minus the cosine of 2 theta plus c. And I waited until the very end to put the plus c. In my mind, it was still wrapped up in these integrals here. You know what? Just for good form, I really should say plus c in the previous step, because I have the integral on one side and then this expression on the other side. But now I have this issue where I've used c twice in the same problem. But notice here it's 5i is equal to this thing plus c. And then next step I have divided by 5. So these c's are actually different c's. So I'm going to call that c1 in the previous step. And then my final answer will just have plus c as our constant. And that is our final answer, folks. Now, early on in this problem, I led us in the direction of u equals cosine of 2 theta. That wasn't necessary in this case. It's actually equivalent if we had let u equal e to the negative theta. The reason I didn't do that is because to anti-differentiate the cosine of 2 theta, we would pick up a 1/2 as a factor out front, which is fine, but I just decided to avoid the fraction this time. I encourage you to go through this entire process again, except pick u is equal to e to the negative theta and dv is equal to the cosine of 2 theta d theta. I encourage you to do that, go through all the steps and ensure that you get the same answer. You will, I've done it both ways.